And finally, just a little bit of help for you in your in-class exercise. So if you remember, whenever we dealt with a new type of data structure, we usually did a portion where we try out things manually. For example, if you remember the link class that we used for the linked list, we had an in-class exercise the first time as a warm-up just to allow you to manually get used to setting various pointers to one another. So your first step is going to be to write the bin node class itself. The bin node class is going to be amazingly similar to the dlink class, although we're going to call the variables left and right. However, just as before in the dlink, we had prev and next. Well, that's a little different than what we're going to be calling left and right. And these then are the getters and setters that you'll need. And inside you'll have 3 private member variables. They will be of type bin node star, and char, because we are using char for our payload in this case. Okay, that shouldn't be too bad, and get your bin node class itself set up and working. Now what we're going to do for today's application is we're going to be converting infix notation to postfix notation. So we're going to go through a little bit of this now. This is algebraic, and it's got a lot of parentheses in it. And if you were asked to do this, you'd probably have to work through from inner parenthesis to outer parenthesis, kind of expanding it through. However, if we use a tree structure, we can actually put this into a sequence that'll allow us to go just from left to right. Let's get started with reverse Polish notation. So normally we would say 2 plus 3. That's probably what you learned in elementary school. And then 2 plus 3 is going to have a value. The value is 5. The other thing that we could do, though, is we can say 2, 3, plus. And that's probably unfamiliar with you, but you say, okay, give me a 2, yeah, give me a 3, okay, now add them together. So that's the idea of postfix notation, in that the operators come after the arguments. So 2, 3 plus, well, that would mean that you take these 2 arguments. So you're going to take the 2, you're going to save it, you're going to take the 3, save it, and then you're going to hit the plus, and you're going to add those 2 together. Now, this ends up being 5, and this is postfix. And then this is infix, because it's in the middle. And you can do a plus 2, 3, that ends up being 5, and this is prefix. And you might want to say, whoa, that's a pretty crummy thing. You'd say add stuff together, but you don't even tell me what it is. Well, this prefix notation you've actually been using, because I know that we can use the operator plus, but if I did have a function like add, well, that's kind of what we've been doing for this prefix notation. We give the name of the operator or the operation, and then we give it the arguments. So prefix kind of happens like that. You tell it the function name, and then you give it its argument lists. Now this will be unfamiliar to you, but it turns out that it's very useful. Okay, so how do we represent a tree? How would we represent a tree that has different operations? So let's say I had a 2 times 4 plus 5. All right, what would you do for this? Well, you'd go 4 plus 5 is 9, and then I'd multiply 2 times 9, and I'd get 18. How could we represent this in a tree? When a tree, the inner nodes are all going to be operators, and then the leaves are going to be the numbers. So for example, I have to do 4 plus 5. One way that we could do this is we can represent the tree that says 4 plus 5, 4 plus 5. And then what do we need to do to that? Well, we're going to need to multiply that times 2. So this would be an example of turning this infix notation into a tree where the leaves are going to have the constants, and then the inner nodes are all going to be the operators. So for this, if we did an in-order traversal, what would we get? Well, we'd get 2 times plus, we'd get 2 times 4 plus 5. That's if we did an in-order traversal. But what the assignment for today is to do a post-order traversal, meaning you would do 2, and then you'd wait for this. So you do 2, and you're all the way down here, and then you do 4, 5 plus times. So we would have a 2, and then a 4, 5 plus, and then a multiply. And this would be postfix notation. Now, it's probably unfamiliar to you, but I'll show you an example of a calculator that does this. So this calculator here, we've got it on, and I want to do a 2, 4, 5 plus times. So I do a 2, and I have to enter that in, and then I do a 4, and I enter that in, and then I do a 5, and I enter that in. Now, instead of entering in a plus, what I'll do is I'll just hit the plus sign. So I'll hit the plus sign here, and what will happen is it'll take those 2, and then this 4, 5 plus ends up getting turned into a 9. And that's what we have here. The 4, 5 plus got turned into a 9. And then now we've got a 2 and a 9 on the stack, which is what we'd expect. And then we hit the multiply button, and we get 18, which is what we had before. It's not readily apparent, but this is reverse Polish notation, and it's fantastic, and it's awesome, and it's what real engineers would use. I don't know what's going on with the high schools in this country, with the TIs and their Infix notation. It's a travesty. I weep for the future. In any case, so what we're going to need to do then is take a expression like this, put it into tree form, then you'll have a discrete variable name for each of these nodes, and then you'll have to stitch them all together. Okay, and that is with, you'll have to turn this into a tree and a operator tree, and I would start probably by drawing it in the middle here where you have the inner parentheses, and then work your way out. But the operator tree itself is not infix notation, postfix notation, prefix notation. That operator tree is, you could read it a number of different ways, like 2 times 4 plus 5. And so it's be 2 times 4 plus 5. Well, if you do an in-order traversal, you'll get infix notation. If you do post-order traversal, you'll get postfix notation, and so forth. Okay. And then if you want to try out a reverse Polish notation, there is an online calculator here that you can use. And then for printing expressions in reverse Polish notation. So that's going to be a part of the assignment where you do a post-order traversal. Remember that we have the order for the procedure for post-order traversal is we traverse the left, we traverse the right, and then we print the node. All right, so how do we do that? What we would do is have a recursive call at this point. So if we had a function, that function can take a node as an argument. Okay, so it would be something like okay, and you're going to need more lines than that. But what you can do then is we're doing a post-order traversal. Okay, so we're going to call, so remember we traverse left, traverse right, and then we print node. Okay. Well, what would we do for traverse left? Actually, we would call pre-order on node's left child. So this is actually going to end up being a recursive call. And this would be node, and then I'm going to leave that for you, what you'd need to do. So you're going to call pre-order on not the node itself, because then we'd be in an infinite loop, but we'd have to call it on the left subtree. So the node, remember, has these functions here. They have get data, get left, get right. You're going to have something in there, but you want to call it on the left subtree, and then the right, and then here you'd have something just like a cout. Something here. So that's the pre-order traversal. Then handling the special cases. These are recursive calls, so we have to have a base case. There's two different ways that you can do it. One, before you traverse left, check to make sure that it's not empty. And before you traverse right, make sure that the right subtree is not empty. And then you can print out yourself. The other thing that you could do here is test to see whether this node is null at all. If it is null, then you just return and skip out of all of this. So there's the last one is a more elegant way to do it, but it's not as clear as far as thinking about how that would work. So you can either handle it before these calls, but remember, this recursive call, you have to have a base case, whether the base case is handled in here or whether or not you just have a total, just a base case up here. Make sure that you're able to do it. Okay. Once you set up your operator tree, then you would call your post-order traversal. Oh, okay. So I noticed what I said pre-order here. I'm not sure why I did that. This is going to be post-order because we do printing the node last. This is post-order. And so then this is post-order. And then the in-order traversal, you can do it. All you have to do is switch two lines. However, you're going to have to handle the parenthesis in this case, or else you'll just get a big old glom of characters. All right, so we're going to set to task. There is no template available here because part of the assignment is to actually write the bin node class.